I've been 3D printing for quite a long while. My first 3D printer was an Ender 3, which I bought while I was in graduate school, when I was doing my undergrad, actually, in mechanical engineering at Innov8 University of Science and Technology. I specialize in product design and additive manufacturing, so it felt quite interesting that I could go from design to prototyping so quick, and I needed a 3D printer for that. So that's what inspired me to get in a 3D printer, and fast forward to today, I'm a 3D print expert at Innov8 Hub. When it comes to design and prototyping, currently at the Hub, we have the FDM machine, the SLS machine, and the SLA machine. And understanding the use case and the function of that part helps me decide on the kind of material, the type of machine to use, and how I should slice it on the software before going ahead to print. So this the understanding is the first phase. Second stage is choosing the kind of material to use, and the third stage is actually making the print, and the last stage is testing out, like trying to run diagnostic to know if it came out fine, and maybe if it doesn't come out fine, we go back, take a step backward and keep doing. That's why it's R&D, we keep trying till we meet the quality. But most of the time, it comes out great. I love to use PLA because PLA is such a wonderful material. It has low printing temperature. It doesn't warp when it prints. It's just easy to use. But again, I can't just use PLA for everything. Although it's nice to print with, it doesn't have a lot of mechanical properties. Like, it's not so strong compared to ABS or PA12, which is polyamide, and other mechanical filaments, ASA included, ASA. Complex designs are one of the most challenging things when it comes to manufacturing. And that's like the best thing about additive manufacturing. Additive manufacturing is a groundbreaking technology or innovation that allows you to manufacture or to bring complex designs to life, because there are some designs or products that can be manufactured using conventional milling processes or casting processes or manufacturing processes. So additive manufacturing plays a key role. So how I ensure the precision and quality of my print is I need to know where they want to use this print. The environment, the use case is very important because it has to look good, it has to feel good, and it has to be functional as well. For example, there are materials that doesn't do well with high temperatures, and there are also materials that do well with high temperatures. So understanding what kind of material selection that we need is by knowing the project it is being used for. That's how I ensure the quality and precision as well. Well, the project I'm very proud of and was quite a bit challenging was building the PET bottle machine. It's part of a project that came with the previous set fair program that we ran at the Hub. So this project is about turning plastic bottles into 3D printable filaments. We purchased the instrument and assembled them at the Hub, and it had a lot of prints. We are talking about up to 300 parts, and it got to a point where precision was really playing with me when it comes to the kind of material that I chose at some particular places. So I had to couple, test, and it kept on failing, but so I ended up winning, and everything came out nice. So yeah, that's like the project. It's actually an exciting project, to see that you can convert plastic bottles from the waste, which is a very big nuisance in the environment, and turn it into treasure, which you can use to 3D print anything that you can imagine. So that's why I'm very proud of it, because it plays a very significant role in the environment when it comes to waste management. I'm a product designer, and I'm also a mechanical design engineer as well. And one thing that we product designers or mechanical designers share in common is using softwares like GrabCAD. So GrabCAD is a software where you go to download 3D models. While going through the software looking for parts to download for a project, I saw this competition that was hosted by GrabCAD, but it's a NASA competition. So it's kind of like a partnership between NASA and GrabCAD. So when I saw it, I summoned courage and decided to compete for this contest. So it's about transferring fuels from one vessel to another in space. So, well, we are talking about cryogenic fuel transfer. And cryogenic means something that is very, very cold. I mean, minus 200 something degrees cold. That's like the coldest you can you can get to freezing anything. I saw the contest. I decided to. It's a design contest, so I decided to participate. And fast forward to 3 to 4 months later, I got an email from GrabCard and NASA congratulating me for winning the 3rd position, and I was let's say I was happy, but I aimed for the 1st position, so it was something. At least today I can boast to be the 1st Nigeria to win a GrabCard competition on that space.